Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. So we meet again. So today we are going to learn a new topic which is coordinates. This is in level form 2. So let's start. So the learning objectives today is to understand and use the concept of distance between 2 points on the Cartesian plane. 2 points, it must be 2 points on a Cartesian plane. A Cartesian plane is where you have the y-axis and x-axis. Okay, next one. The learning outcome is that you'll get to find the distance between 2 points with common y coordinates and common x coordinates, where this one you'll get to see the points might be in the same y coordinates and might be in the same x coordinate. And number 2, you'll get to find the distance between 2 points using the Pythagoras Theorem. So do you still remember what Pythagoras Theorem is? So the Pythagoras Theorem, the formula is c square equals to a square plus b square. Okay, the Pythagoras Theorem must be in a right angle triangle. Okay, so c will be here, the hypotenuse, a will be here, and b will be here. Okay, so next step. So now the question is, how far is your school from home? How do you measure the distance? Okay, normally we have we travel by cars, right? Through the highways and probably using the road. No one's getting to school by walking, right? So how do we measure distance? Normally we just see the kilometer in the board, in the highway board. Then we know that the distance might be in 100 kilometer or 20 kilometer. 20 kilometer is very near. No. Now, do you know what is distance? Distance is length between 2 points. Length or distance. This is distance actually. Distance is what we call as length as well. Length. Okay, so this is where you will find out the common x coordinate. What is common x coordinate? If you have 2 points, let's say point A and point B, so A is at coordinate 2, 1, B is at 2, 6. The common x coordinate means that they both share the same x coordinate. So that what it means by the common x coordinate. Okay, so if we want to find the distance, what you need to do is you just need to hop 1, 2, 3, 4, 5. There you go. That's your distance, 5 units. As easy as that. Or you can just calculate how many boxes, small boxes here. 1, 2, 3, 4, 5. Or the other way around is that you take the highest value of the y and you deduct it with the lowest value of y, and you'll get x 5 units. Okay, let's read here. If x coordinates are the same, the distance is the difference between their y coordinates. The difference between the x coordinate, the larger value will be minus with the smaller value. Okay, so this is easy. If you see that the x coordinate is the same, so definitely you will have to deduct the y coordinates. Okay, easy, right? Now let's look at the common y coordinates. The same one with x coordinate, where if you have 2 points, let's say you have point C and you have point D. Remember, first thing first, remember something. What do you think that I want to emphasize? Remember, distance cannot be negative. Distance must always positive. Okay, wait, okay, so in this case, you see that what is the value that is the same between C and D? What is the coordinate of x or y that is the same for C and D? So you see that the same coordinate is y. That's why we have common y coordinates. So what we need to do is that we just need to multiply the difference of x. You see, -6 and 1, which one is greater? Which one is bigger? So you know that 1 is bigger than negative 6. So what you need to do is that you just need to minus 1 minus with negative 6, which is equal to 7 units. Or the easiest way, or if you have your Cartesian plane with you, you just need to plot, and then you just need to hop 1, 2, 3, 4, 5, 6, 7. So there you go. You got 7 units as well. Easy, right? Okay. Same goes with the x, the common x coordinate just now. The y coordinate are the same. The distance is differences between their x coordinate. The difference between the y coordinate, the larger value, minus with the smaller value. Okay. Okay. Same goes with this one. We must have to minus. Just now we have minus, and the next one we also have to minus it. Okay. Okay, next. Just now we learned about when the coordinates is the same. The x is either they share the same common y coordinates or the same common x coordinate. Now what if they don't have x or y that is common? In this kind, for this example, distance between 2 points. Yeah. Okay, find the distance between point P 2, 1 and point Q 8, 9. So we have 2 points here. One is Q and one is P. Now you cannot calculate the distance by doing like this, because if you see, they don't have what? The same distance between another box to another box, right? You see, that is impossible to do it. Now, you see, it's not the same. So what we need to do is that, first thing first, let's look at the steps. First, draw a right angle triangle joining point P and Q. Because if you want to find distance between these 2 points, you have to remember that we have to use the Pythagoras Theorem. So, first thing first, draw a right angle triangle joining point P and point Q. It's okay if your triangle looking like this, not a problem at all, as long as it's a right angle triangle, no problem. Number 2, label the point of intersection of the 2 lines. Yes, there you go. So we have to know what is another point that making it a right angle triangle. If you have a right angle triangle, we have to know that there must be 3 points, right? So number 3, count or calculate the number of units for length PR and QR. So another way to do it is, okay, now we have our R here, and we have our R here, we have our P and Q here. Now what you need to do is that, other than using the Pythagoras theorem, let's calculate one by one. So for PR, we have the unit is 1, 2, 3, 4, 5, 6 unit. Excuse me. And for QR, we have 8 units. PR 6 unit and QR 6 unit. So what can we do with it? So another formula other than Pythagoras theorem is, let's just use Pythagoras theorem, yeah? By using the Pythagoras theorem, calculate the length of PQ. Okay, we have to use the Pythagoras theorem. Okay. So we know that our Pythagoras theorem is this one, C or PQ. So we know that our PR is equals to 6. So we put 6 here. Remember, Pythagoras theorem is C square equals to A square plus B square. We want to find C, then you have to make sure that the square is being transferred to the other side, and it will be the square root. So it's supposed to be A square plus B square. So the B square is our 8 square. So if you multiply this, if you square it if you square it, so 6 square is equal to 36 plus 64. This is equals to square root 100, and square root 100 is equals to 10. So the distance of PQ, so we can say that the distance of PQ is equals to 10 units. Why do we have to use units, not cm, not meter, not kilometer? Why? Because we are doing it in Cartesian plane. When we use it, when we calculate it in a Cartesian plane, we have to write the units in units. Okay? We have to write it in units. Okay? Next one. Okay. Okay. Same goes with this one. For this slide, wait, I'm going to take this to the previous slide. The previous, this one slides shows you did not need to calculate, you don't need to calculate the you didn't need to minus the coordinates. You just need to find the how many boxes from P to R and how many boxes from Q to R. The other way round to find it is by minusing the coordinate. Okay, deducting the coordinate. Okay, just now we have our R to be wait, yeah. In this case, our coordinate R is 6, 3, right? Why it's 6, 3? Because it share the same X for A and R. Okay, I need to change this to C. Okay, C. 6, and because this is a origin, so this is 3. They are sharing the same common Y. Okay, so how do we do this? Because for B and C, they have the common Y. So what we do is that we take the highest value, 6, we minus it with the lowest value, -2, then you get 8 here. And for this one, 6 is the same. They share the common X. So what we do is that we take the highest value, 9, minus it with 3, the lowest value, 3. So it will be equal to 6. So the Pythagoras theorem, so the distance of AB is 6 square plus 8 square square root, where it will be equals to 10. Okay, super easy, right? Okay, so let's do this question together. Distance between 2 points. By using Pythagoras theorem, find the distance between point A 9, 4 and point B 5, 2. So in this case, let's try this. So this is X. X, X. Wait, yeah. If the question did not give you any diagram on to do it, you can either use diagram, you take your you draw your own Cartesian plane, or the easiest way is just labeling your X and Y. So this is your X, this is your Y, this is your X1, Y1, so this is your X2, Y2. Y, X1, Y1, point A we considered as 1, the first point. B is the second point, so that's why they got all 2. Okay, the second point, yeah. Okay, so let's compare this. So we say that 9, because 9 is the highest number, minus with 5 square, plus it with 4, minus with 2 square. Remember kids, this is just the same as doing the Pythagoras theorem, where it's supposed to be A square plus B square. Okay, sorry, I should not have this square here. Okay, so what I do here is that A is the deducting my X coordinates For B is deducting the y coordinates. Okay, that's not a problem when you did not be given the diagram. You can still solve the question. So 9 minus 5 square, it's 4 square. 4 minus 2 is 3 square. So this is supposed to be 16 plus 9 square root. So this is supposed to be square root 25, and square root 25 is equals to 5. Easy, right? Okay. So this one as well, you have the value. So this is x. So this is your x. Label first x1, y1, so that you will not get confused at the end of the day. So this is x2, y2. Okay. So x1 minus x2 square plus y1 minus y2 square. Okay. Right. So you will get 5 square plus negative 12 square. So you will get 13 square. Sorry, 13 unit. Okay. Next one. Okay. So this is the only formula that you need to understand. The only thing that you need to understand, Pythagoras Theorem. Which is C equals to square root A square plus B square, or you can use x1 minus x2 square plus y1 minus y2 square. Both are the same. Okay. Okay. If you got any problem with this, please let me know. Okay.